All right, we're going to look at the 2x2 system of equations. So 2 equations, 2 unknowns. I put up there substitution method, if at least one equation solved for x or y. Addition, elimination, or linear combination method, if they're both in standard form. So just to kind of review those 2 ideas, if I'm seeing in a system a y equals or an x equals, I'm going to think about a substitution method, using that method. Standard form looks more like this to us, like 2x plus 3y equals 7, where we had like x and y on the same side. That was a standard form. Okay? So if I see that for both equations, then I'm thinking about these methods. Now these are all the same methods. Addition, elimination, linear combination. It just depends on the teacher, the textbook, the materials, whatever. They all mean the same thing. Addition means we're going to add them. We're eliminating a variable when we do it, and we're combining them by addition. That's all it's referring to. So just 3 different terms that mean the same thing. You see some of those different ones. Now, what we're actually looking for. I'm going to give you a visual here. We're looking for where 2 lines in a coordinate plane intersect. So let's say I had a line going up there, another line going this way. So the intersection point would be right there. Okay? So the solution to the system would be the intersection point. So this is what we would call a consistent system, and there's one ordered pair solution. One ordered pair solution. So what's the solution? Well, whatever this value is, x, y. You know? The graphical kind of gives you a good approach to it, good visual of what's going on. But you could tell in the graphing, if I really wanted to find that solution, I would have to estimate where it is. Okay? Maybe if I was drawing it using a computer or something, I could see exactly where that intersection point is. But otherwise, I'm just kind of guessing. Okay? I could also see where there could be 2 lines in a plane that never cross. Okay? And so those would be, you've seen that before, that's parallel. Okay? So this would refer to an inconsistent system. And the way I think of it is just parallel. They're never going to cross. So since they never cross, this would be a no solution. There is no point where they cross. No point anywhere in the coordinate plane where they're going to cross. They're parallel. The third type, you've got a line here in the coordinate plane, and the second line lays right on top of it. Lays right on top of it. This is what we call dependent. Also referred to as it's the same line. It's dependent. One's depending on the other. They're laying right on top of each other. They're the same line. This would create infinite solutions. Now, we're going to have to do some algebraic work to get these things solved. But what we're looking for is where they cross. We want every one of them to have one ordered pair solution. We're going to run into some that don't have a solution because they're parallel, and we'll run into some that have infinite solutions because they're laying on top of each other. So in other words, there's an infinite number of points they cross at. Now just think about this. If you were to draw 2 lines on a piece of paper, they're either going to cross one time, never cross, or you're going to have one laying right on top of the other. Okay? You can't draw something like this because one of those isn't a line, it's a curve. Remember, lines are straight. All right? So wherever you're going to draw them, they're going to intersect at one point, never intersect, or always intersect. It's the only 3 ways it could happen. Okay? So when we're solving a 2x2 system, So these are linear equations. We're trying to find the x and y point where they cross at. Algebraically, if I saw something like this, let's go 3x minus 2y equals 5. Okay. Here's our one equation. And we'll make the other equation y equals 2x plus 1. Okay. I need to work with what I'm given. So I'm given a situation here where one of those equations is solved for y. That's going to limit me to a substitution method. As soon as I see one of these solved for a variable, I am thinking substitution method. This means I can substitute this 2x plus 1 in for y. So I can substitute that in. When I do that, 3x minus 2 times 2x plus 1 is 5. The best part right here, I've solved equations before. I'm back to solving an equation. Okay. That one substitution step has put me back into something that I'm pretty comfortable with. Let's see, 3x minus 4x minus 2 is 5. Let's see, that would be negative x. Add my 2 over 7. X would be negative 7. So I did get an x value. That means this is going to be what we call a consistent one. There's going to be an ordered pair where they cross. But my solution is going to be that ordered pair. So once I have x, I need to back substitute to get my y value. Now you can put this x value into the first one or the second one, whatever's easiest. For me, I'd probably put it in the bottom one here. Y would be 2 times negative 7 plus 1, negative 13, which means my solution is negative 7, negative 13. There's the ordered pair where they're crossing. Okay. So visually, this point's where we're seeing these two lines cross in the coordinate plane. Algebraically is going to help get us that exact value versus looking at some graph and guessing what the value is. We're kind of estimating. Are you okay there? Now, substitution method. See a couple variations here. If I saw x equals 4x, not 4x, 4y minus 3, and I saw x equals 2/3 y plus 1. Looks a little strange with both equations x equals, but this is still going to limit me to my substitution because at least one equation solved for x or y. In this case, both of them are. Other things that typically like to throw us, fractions. Okay? We're not worried about that at the moment. I'm worried about what method I'm trying to use. When I'm looking at this, they're both x equals. I can do a substitution method. Send that guy right in for x. So now I'd have 2/3 y plus 1, 4y minus 3. All right. The fraction comes into play. This is our solving equations. Right? We've solved equations with fractions before. What you should remember is the first thing we typically do is we just get rid of the fractions. Because if we get rid of the fractions, it gives us something a little bit easier, okay? So this is where in the past, to solve this, we've multiplied everything by 3, and that would eliminate the fraction. So if I multiply everything by 3, I'm going to get 2y. I'll just write out here to the side, multiply by 3. It gives me 2y plus 3, 12y minus 9. Now, it didn't really solve it, but for most of us, that tends to look better with no fraction sitting there. Finish out our solving. Let's say move my 2y over, so that's 10y. Bring the 9, that's 12. So y would be 12/10 or 6/5. So there's my y value. We're going to end up with some fractions sometimes. I need the ordered pair. This is still telling me I'm looking at a consistent one. I know I've got an answer. There's a point where they're crossing. If y is 6/5, if I put that back in, I'm just going to go in the bottom one. 6/5 minus 1. Again, it doesn't matter. Personal preference. You got a fraction here. I don't think the top one's any easier than the bottom. It doesn't matter which one you use.
Why did you subtract 1?
Because I wrote that wrong. +1. That should be a +1, not a minus. All right. So let's see. 3 goes into 6 twice. So we're going to get, what I got there, 4/5 plus 1. And common denominator is going to give me 9/5. Okay. My point is 9/5, 6/5. That would be my ordered pair where they're crossing. Okay. Substitution, what I want to use when I see a y equals or an x equals, and I don't care which one. Okay. Elimination, or as I said, it could be called addition or linear combination, something like this. Let's go 2x plus y is 3. 3x minus y is 2. So this would be that elimination method. So what I'm looking at here, I've got both equations in standard form. In other words, I've got x and y on the same side for both equations. What I want to be able to do is add the two equations to eliminate a variable. That's why it's called elimination. If I add these, look, the y's are going to go away. I got a plus y and a minus y. So I have 5x is 5. X then is 1. So by adding the two equations, eliminates the variable. So I've got x is 1. Well, now I need to know what y is. Does not matter. I'm going to pick the top one. And again, I'm picking that top one to put the 1 back in, just personal choice. There's nothing else to it other than that. Okay? I know for me, a lot of times I'll avoid the negatives because that's where I make mistakes. Matter of fact, I made one a few minutes ago right there when I had the minus and it should have been a plus. Okay. So now I'd have y as 1. And so my answer would be 1, 1, 9.11. Look okay? All right. Now, basic idea of elimination. We want to add, variable goes away. Let's look at some variations that we could see. Let's go 3x minus 2y equals 4. And let's go 5x plus y equals 2. Now I'm thinking elimination again because I see them both in standard form. So I would really like to be able to just add the two equations and then a variable goes away, but it doesn't happen. If I add the x's, what do I get? 8x. If I add the y's, I get negative y. Okay? So this is where I need to first decide which one I want to get rid of. In this case, I'm going to get rid of y. I'm trying to decide which one I'd like to get rid of. Most of the time, it doesn't matter which one you pick. Okay? I picked y because I see a minus and a plus. I see a 2 and a 1. Man, I sure wish there was a 2 right there. Because if there was a 2 there, when I add it would go to 0. So if I want a 2 here, I can multiply everything in that bottom equation by 2. That's what I'm looking for. So my first one, 3x minus 2y is 4. My new bottom one, 10x plus 2y is 4. And now that's giving me a situation where that addition or elimination method will work. So sometimes I've got to create a situation for that to happen. If I add now, 13x is 8, which means x is 8/13. Now, most of the time, we don't end up with such bad fractions and stuff, but it's going to happen every now and then. There's nothing we can do about that. And that's okay. We still got to be able to substitute it back in. So if I use x is 8/13, I can use my top original, bottom original, or even the bottom new one. And this is a situation where I don't really know if one looks better than the other. Okay. I'll go with top one. Let's go 3 times 8/13 minus 2y is 4. Now, sometimes it's nice to get fractions in here because we can kind of practice with the fractions. We know fractions kind of give us trouble sometimes. If I multiply this, 24/13 minus 2y is 4. Okay. So let's think ahead here. I'm going to have to subtract the 24/13, then divide by the -2. You really have 2 choices here. That's one of them. Subtract the 24/13, divide by the -2. If you're not comfortable with fractions, well, then multiply everything by 13 and get rid of them. There's where your second choice is. If you don't mind fractions, subtract it over, divide. If you don't like them, I'll multiply by 13. 24 minus 26y is 52. And no, it's not solved, but it looks easier to solve if I don't like fractions. Okay. That's where we've solved equations with fractions before. Coming back using it again. Let's see here. What would this be? Negative 26y, 28. And so then y would be negative 14/13 when it reduces. Okay. Remember, you have ways to deal with fractions if you're not comfortable with them. And let's see. That would be my answer. 8/13 negative 14/13. Okay there? Let's look at a little different setup here. Let's go 5. 3x plus 2y equals, what do I have here? 3x plus 3y equals 0. There's my first one. And 4x plus 2y is 3. Still standard form. I'm looking to do elimination. I look to add 3 and 4, 7. 3 and 2, 5. Not really working for me there, okay? Nothing's going away. So I'm going to need to create a situation for it to go away. I can pick either to get rid of the x's or get rid of the y's, but I got to pick one of them. What do you want to get rid of, x or y? Y. Y? All right. So I'm looking at these 2 numbers. So my first thought would be, what does both a 2 and a 3 go into? They go into 6, right? So if I multiply the top one by 2 and the bottom one by 3, I will get 6's there. One of them, though, has to be negative because I need opposite signs. Because if I put this in, I'm going to get 6 plus 6, that's 12, right? I need a 6 and a negative 6. It does not matter which one you make negative. I'll pick the one on the bottom. Again, because I'm trying to get opposite signs. 6x plus 6y is 0. Negative 12x minus 6y, negative 9. Now when I add them together, negative 6x, negative 9, x is 3/2. Here's my x value. I really want things to just add out like they did in number 3. Sometimes I have to adjust one equation, like number 4, to make it happen. Sometimes I've got to do it to 2 of them. Right? Now, if you chose get rid of x, it wouldn't change anything. Right? If you chose get rid of x, you'd have to do this one times a 4 and this one times a 3 and one of them negative. It's not going to shorten it up. We just got to pick one. X being 3/2. So if X is 3/2, I've got to go back into any one of my 4 equations. Any one of my 4 equations. I have the 2 original. I have the 2 new. Doesn't really matter. I'll pick this one. 6 times 3/2 plus 6y is 0. And again, why am I picking that one? I feel like it. It's all I'm looking for. I'm trying to find one that I can work with. Okay. 2 goes into 6, 3, so there's 9 plus 6y is 0. Let's see, 6y is -9, so y would be -3/2. Y would be that -3/2. Making my answer 3/2, -3/2. There's my ordered pair. So every one of these so far, we found an ordered pair solution. There's a point where these 2 lines cross. Let's look at one where we don't have a point where they cross. Let's say we have this. Let's go x plus 3y equals 7. And let's go 2x plus 6y is 14. Now I said this isn't going to give us that single point where they cross, and that's fine. But look at the problem. It's still set up for that elimination method, all right? Where I'm going to try to eliminate a variable. That's all I'm focusing on right now. If I want to get rid of x, I can multiply the top one by -2 because I'd sure like a -2 here to go with the 2. So if I do that, -2x minus 6y, -14. Bottom one, 2x plus 6y, 14. And then look at what happens when you do the elimination part. When you add them, both variables disappear. I don't have anything left on our left side. Okay? So what that tells me is I've got one of my 2 special cases. So let's see here. If I add these, I get 0 equals 0. Okay? So when I lose my variable, lost variable. So obviously when I added them out, the x's and y's went away. Okay? That's fine. Okay? I need to examine what's left. Okay? So if I lost a variable, I don't have an x or a y to solve for, which means I'm not going to get an ordered pair. Okay? I don't have x or y. If I lose the variable and I have a true statement, this would be infinite solutions. So back to those graphs we started with, this would mean that one line was laying on top of the other. In other words, they were the same line. It's dependent. We would say infinite solutions. Now, as far as the true statement, just look at what's left. 0 equals 0. That's true. 0 always equals 0, right? That's what's giving me infinite. If I saw 0 equals 4, that'd be false. That would be no solution. To kind of give you another look here, what if this 7 was a 5? It wouldn't change my process of solving, but -2 times 5 is -10. Cancels, cancels. 4. Lost my variable, but that's false. 0 doesn't equal 4. Okay. So this would be, all of a sudden I have a false statement, which means no solution. So what that's telling you is these 2 lines are parallel, like we saw in the beginning. There would be no solution there. So I'm looking real quick right here. One of the first things that usually gets to us is all of a sudden we add and everything goes away, and typically we think, well, we did something wrong. Everything disappeared. Okay. Go back, check your work. Hey, we didn't do anything wrong. Now let me examine what I got left. If I had a true, like a minute ago when I had 0 equals 0, infinite. In other words, everything works. If I have a false, that means nothing works. So that's where I get my no solution. So when these show up, they usually work out pretty quick. Downfall is usually we think we did something wrong a lot of times. The other look that we're going to see from time to time goes back to the old fraction idea. If I had 2/3 x plus 1/4 y equals -2, and I had 1/2 x minus 1/3 y equals 1/3. That is not a good looking system. Okay? Those fractions are everywhere. What we want to remember is standard form, x and y on the same side, was not just x and y on the same side, it was also no fractions. Okay? If I saw something like this, my first course of action is going to be just get rid of the fractions. I mean, unless you really want to work with all the fractions, if you get rid of them, they go back to something like this. Okay? So I'm not worried about solving the equation right now or the system. I'm worried about the fact that, man, I don't like fractions. So I'm going to multiply that one by 12 and this one by 6 because that would be the common denominator. I'm just trying to get rid of the fractions and then see what I have left to deal with. 3 goes into 12, 4 times 2, 8x. 4 into 12, 3, so plus 3y, negative 24. 6, 2 into 6, 3, so 3x. Minus 3 into 6 twice, 2y. 3 into 6 twice. There's my new system. Now, it's not solved, but you have to admit, this system right here, these two, look a whole lot better than those original two of all the fractions. Right? That was the purpose, and that's why in the past, when you solved equations, they had fractions in them, one of the first things you did was get rid of the fractions. That same kind of concept keeps coming back around. Now I'm in that elimination mode. I've got to choose x or y to get rid of. You're going to have as much work on both of them. Right. Let's say we get rid of, let's go y. If I want to get rid of y, I'd multiply the top one by 2 and the bottom one by 3 because that's going to give me a 6, then a negative 6. I don't have to worry about a negative because I do have opposite signs. Okay. So this will give me then 16x plus 6y. Negative 48. Bottom one, 9x minus 6y is 6. Now the y's go away. I've got 25x equals negative 42. X is negative 42 over 25. Yes, another ugly fraction. You're not going to have a lot of those at this point. But I'm just kind of getting some problems up here so we can see some different forms. Notice my first step here was I don't want those fractions in the problem. I can get rid of them. Then I can go through my solving process. Is it going to be a pain maybe to put negative 42 25ths back in? Yeah, maybe, but I'm not going to put it back in these two. I'll pick one of these. All right? Big deal there, okay? And then once I put it back in here, then I can deal with the fraction from that point to complete my ordered pair. Is everyone okay there? Do you want me to work through putting that x back in? Okay. Do it. Which one you want? Top or bottom? Because I don't want that. 3x? Okay. So I'm going to go 3 times negative 42 over 25. Minus 2y equals 2. So now I'm going to have 3 times negative 42. What is that? Negative 126 over 25. Minus 2y is 2. Now, if you're like me, that does not look like something I want to solve. So what I would do is I just get rid of the fraction right here. So that means I'm going to multiply everything by the 25. I agree, not the best looking problem, but if I multiply by the 25, I get negative 126 minus 50y equals 50. I know I've got big numbers there, but that looks a whole lot better. I'm going to add the 126 over and then divide by the negative 50. So I have negative 50y, 176. Y would be negative 176 over 50, and that'll actually reduce to, what is that, negative 88 over 25. Yeah. If you get those fractions, get rid of them. Okay? If you got a calculator that does fractions, well, fine, use it. If you're comfortable getting common denominators, do it. But if you're not, and I can tell you right now, I don't mind some fractions like 2/3 and 1/2. I don't really want to deal with negative 126 over 25. But I know I can multiply by 25 and get something easier to work with. That's kind of my idea there. That's what I'm going to deal with for that piece. Everybody okay there?